Hello friends, I cordially welcome you to my YouTube channel, Chemigeek, where we are going to dynamize our knowledge through problem solving. So today we have a problem in front of us on classical mechanics and thermodynamics for physical chemistry. This problem goes like this. Suppose a certain metal rod is utilized to measure the temperature of an unknown system. At 0 degrees Celsius, if the rod's length is 27.8 centimeter and at the unknown system's temperature, it expands to 28.1 centimeter, determine the temperature of the system. Use the following form of the equation for the linear expansion of the metal rod. L theta is equal to L0 1 plus alpha theta plus beta theta square, where alpha is equal to 1.2 into 10 to the power minus 5 degrees Celsius raised to the power minus 1. Beta is equal to 1.0 into 10 to the power minus 8 degrees Celsius raised to the power minus 2. L0 is the length at 0 degrees Celsius and L theta is the length at theta degrees Celsius. So what we can understand from this question is that there is a metal rod which needs to be utilized for measuring the change in temperature of the system. So basically we have to determine the change in temperature. So we can write down, whenever we are going for a solution, we should write down all the data which is given. So that is why I have rewritten all the data, although they are already there in the question. Still, we should have a good habit of writing the data while we are solving the question. So length of the metal rod L0 is equal to 27.8 centimeter at 0 degrees Celsius. L theta is equal to 28.1 centimeter at theta degrees Celsius. So what is theta? Theta is a random temperature which we have to calculate. So what is the temperature of the system? There is a system in which when this rod is introduced, the rod expands. So expands from 27.8 to 28.1 centimeter. Now there are two constants, one is alpha and one is beta, and these constants have been given in the question, and this equation can be used to see how much will be the change in the length. So L theta, that is the final length, or let's say the length of the rod at the theta temperature, this will be equal to L0, that is the length of the rod at 0 degrees Celsius, multiplied by 1 plus alpha theta plus beta theta square. So now alpha and beta are given. Since theta square is multiplied by beta, that means that beta should have a unit which is degree Celsius raised to the power minus 2, since we are having all the units in degree Celsius. This is a question which we can solve in degree Celsius. We need not convert this temperature to SI unit, that is Kelvin. But generally when we are solving any question in chemistry or in physics, we should have a habit to convert them into Kelvin. It is not required in this particular question. That is why we have not converted. We can directly use this degree Celsius. So when we write the equation, we find that these are the values. So we are rewriting the equation according to their values. That is L theta we are putting as 28.1 centimeter and L0 we are putting as 27.8 centimeter. And alpha's value has also been given, that is 1.2 into 10 to the power minus 5, and beta's value is also given as 1.0 into 10 to the power minus 8. Right? We have not written any units in alpha and beta just to avoid further complication, and we are also going to cancel centimeter and centimeter, as we can see in the next step. So if we rewrite this equation once again, what we find that 28.1 divided by 27.8 is equal to 1 plus alpha into theta and beta into theta square. The same value has been rewritten. 28.1 divided by 27.8 turns out to be around 1.0108. And again, the same thing has been written on the right hand side. That is 1 plus alpha into theta plus beta into theta square. Now, if we take the 1 from the right hand side to the left hand side of the equation, we subtract it and the value turns out to be 0.0108 instead of 1.108. So we are subtracting 1 on the left hand side and the right hand side both. On the right hand side, 1 and 1 cancels, and on the left hand side, it becomes 0.0108. On the right hand side, we have again retained alpha theta plus beta theta square. Now we are again rewriting this, and we are comparing this equation with the quadratic equation. So let us try to see what happens. This is a general quadratic equation. A theta square plus b theta plus c is equal to 0. And if we compare this with the equation given above, we are going to take this 0.0108 on the other side of the equation, and that turns out to be minus 0.0108 from the left hand side of the equation to the right hand side of the equation. Or if we can take the whole thing. The right hand side has been written here in the left hand side, and the left hand side, that is 0, has been written as right hand side. So if we compare these two equations, this equation and this equation both are same. So if we compare these two equations, this A turns out to be 1.0 into 10 to the power minus 8. B turns out to be 1.2 into 10 to the power minus 5. And C turns out to be minus 0.0108. So if we use the quadratic formula, what we have, theta is equal to minus b plus minus root b square minus 4ac divided by 2a. So if you are going to put these values, we are going to get a big equation with all the values, and let us see how to simplify this one by one. So we are putting just the value of b, value of c, and value of a in the place of the quadratic equation. Now, as you can see here, we just need to multiply this 4 into 0.0108, and that turns out to be 4.32 and 10 to the power minus 10. So basically, this if we include this decimal point, if we shift this decimal point twice on the right hand side, so we get 1.0108. So sorry, 1.08. So 1.08 into 4 is 4.32, and this gives 10 to the power minus 10. Now on this side, if we square the whole thing, that is 1.2 into 10 to the power minus 5 square, that gives us this 10 to the power minus 5 becomes 10 to the power minus 10, and 1.2 becomes 1.44, because there is only one decimal place, so its square will have two decimal places, and it becomes 1.44. That is the square of 1.2. So we can see here that for both of them we are getting 10 to the power minus 10, which is under the root. So if we take my 10 to the power minus 10 as common and take it out of the root, it becomes 10 to the power minus 5. And if we add 1.44 and 4.32, we get 5.76. Now we have a common 10 to the power minus 5 for both of these numbers. One is this one and another is this one. So if we take common this 10 to the power minus 5, and we can take 10 to the power minus 8 as also common. 10 to the power minus 5 divided by 10 to the power minus 8 gives us 1 by 10 to the power minus 3, that is nothing but 10 to the power 3. And inside the bracket we can see 1.2, this minus 1.2 plus minus 2.4. Why 2.4? Because root of 5.76 is 2.4. Basically 576, if you take the root of 576, we get 24, and this is basically nothing but 576 divided by 10 to the power 2, that is 100, so that gives 2.4. So these are simple numbers, as we can see. This gives 1 by 10 to the power minus 3. 1 by 10 to the power minus 3 means nothing but 10 to the power 3. And this is 1.2 divided by 2. Why 1.2 divided by 2? If we take the plus, if we take the minus, we get minus 3.6. If we take the plus, so that is why I have written or else. So there are two options. If we take the plus symbol, we get this value, that is 1.2 divided by 2. And if we take the minus symbol, then we get minus 3.6 divided by 2. That gives us the plus 1 gives us 600 degrees Celsius. So 1.2 divided by 2 is 0.6. 0.6 multiplied by 10 to the power 3 is 600 degrees Celsius. And minus 3.6 divided by 2 is nothing but minus 1.8. So minus 1.8 into 10 to the power 3 is 1800, that is minus 1800 degrees Celsius. We can also solve this question using an app which is freely available on the internet. So if we put these values in this app, that is this Math is Fun, you can see the URL mathsisfun.com, and we have a quadratic equation solver here. So we are putting the values as 0.12345 6, 7 and then 1. And in case of B, we are putting 0.0000 and then 1, 2. So that makes it yes. And this one is 0.0108. So if we put these values, we can clearly see, this is going to be this C is minus 0.0108. We can very easily find the roots. See the roots are displayed minus 1800 and 600. As we know, minus 1800, that is minus 1800 degrees Celsius, is not possible, because the lowest possible temperature in the according to the Kelvin scale is minus 273.15, because all the gases or let's say all the matter ceases to exist below this temperature, or let's say the volume becomes negative below this temperature. So therefore this is the lowest possible temperature, so this value is not possible. Only the 600 value is possible. So our answer is the final temperature has to be 600 degrees Celsius, for which we get an expansion of the metal rod to 28.1 centimeter from 27.8 centimeter. So this is how we solve this question. So thank you very much for watching my video. Please like, subscribe and share with your friends that we have a channel. We have a new channel called Chemigeek, where we are going to share many more problem solving videos.